My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 508. In this lecture, we will try to understand training and test data split. We construct a data set. You have the source vertex, you have the destination vertex, and you have the class label. Half these labels are class 1, half of them are class 0. In the previous lecture, we discussed how we constructed the data set. Of course, at the end of the day, we have to split our data into train, cross validate, and test. There is one problem with this. Let me explain the problem to you. So the problem is as follows. In the real world, imagine if I am an engineer at Facebook or Instagram, at time t I am given source, at time t I am given source, destination and yi. Let me say at time t. At time t, you have source, destination and yi. This is the timestamp t. Let it be today. What is this t? Let me assume this is today, isn't it? In the real world, this graph is evolving over time. This graph changes over time, isn't it? This graph changes over time. If I say after 1 month, yes, after 1 month means what? At t plus 30. 1 month means what? What is the meaning of 1 month? T plus 30. 1 month means what? T plus 30. This graph changes over time. If I say after 1 month t plus 30, today is t. T indicates today. T plus 30 means after 1 month. Today is t. After 30 days, this graph would have changed because some people would have following other people. So this graph is actually changing over time. So if you think about this, this graph will change, which means this data is actually temporally changing data, isn't it? That's what it actually is. But unfortunately, when it is temporally changing, we need to build our, unfortunately, what is this? We are just temporally changing data. That's what it actually is. But unfortunately, when it is temporally changing, we need to build our train and test data also, taking temporal nature into consideration. Because imagine if I am trying to productionize new model at time t, you are not doing temporal splitting here. Imagine if I am actually an engineer at Facebook or Instagram, I would actually have the graph at time t, also the graph at time t plus 30, isn't it? If you are an engineer at Facebook or Instagram, you will have data at time t and t plus 30. T means today, t plus 30 means after a month, isn't it? This point is very important because I might have the graph for last 2 years, and what I would want to predict is for any model that is being deployed at time t, I would want to predict the edges. I can validate how well the model performs, because once if I productionize at time t, it will start showing recommendations now, and I have the actual values of the user selecting that they are friends or not. This data would actually can obtain if it is in the production over a period of next 30 days, isn't it? So actually I have data that is changing over time. You would be doing time based splitting if you are an engineer at Facebook or Instagram. Unfortunately, we are just given one graph at time t. We are not given the timestamp. For example, imagine if you are given this data, let's say source vertex, destination vertex, and let's assume in the timestamp TS when the source started following destination. Yes, if I am given this timestamp, I can start doing temporal split, isn't it? But I am not given the timestamp. In the real world, if I am an engineer at Facebook or Instagram, I would have this time-based data also. Now, I will actually split it time-based data, and I will use all the previous data to build a model to predict the new edge or new following that will happen in the future. So if I have the timestamp here, I would have done the time-based splitting, isn't it? But since I don't have it, because I'm just given one graph at time t, I don't have the timestamp TS column here in the data set. We are left with the random split, isn't it? Yes, it is important for you also to understand that random split is not ideal thing, isn't it? Random split is not an ideal thing. The ideal thing is time-based split, isn't it? The ideal thing is time-based split, where we will use all the data till time small t to build our model and to predict the model can predict the future followings or the future edges accurately. That's what we actually do in the real world. But because we don't have the timestamp data, we cannot perform the time-based splitting. We will split with the simple random split. We are simply randomly splitting the data. My total graph itself has 9.43 million class 1 labeled pairs of vertices, and I have the same number of class label 0 pairs of vertices, isn't it? Whether you are splitting into two parts, isn't it? We are literally splitting into two parts. This is 80-20 split, because I am using, just see, I am using here, first one is training data, second one is test data. I already supplied this Jupyter notebook, IPython notebook in my previous lectures description, and even in comment section. Please refer that particular IPython notebook. This is 80-20 split because I am using 0.2 here. Just see, test size equal to 0.2. Here my test size, I am using 80% of my data for my train and cross validation. I am using 20% of data for testing. But here we are performing random split, isn't it? I am performing random split, while in the real world it is very important that we are actually performing time-based splitting. But since we don't have this additional timestamp TS column, we have no other option and we have to use random split. We understand that it is not right thing to do, but given that we only have the source and destination vertices but no timestamp, isn't it? But no timestamp. Random split is the best we can do. So we will continue with it, because it's very hard to get real world social networking data. So we have to stick with it. So this is the simple summary of the data itself, isn't it? Just see, here you have 80% of train data, 20% of test data. What is the summary here? We only have the source and the destination vertices but no timestamp. Random split is the best we can do. Just see, if you see this summary here, what it says. Just check it out. With both you have your train and test graphs. You have this is your training graph, isn't it? This is, just check, this one is your training graph, isn't it? So in your training graph you have 1.78. We split the data based on edges. That's important, isn't it? You have 1.78 million vertices in your training data. You have just check it out here, 1.78 million vertices and 7.55 million edges, isn't it? 7.55 million edges. We split data based on edges. We split the data based on edges, not based on the vertices, isn't it? 80% of edges went to training data, 20% went to test data. So this is your test. This is your testing. This is your training, isn't it? Average in degree, and just check, you can check in the training data average in degree. In your testing data also you can check average in degree and out degree in training data, average in degree and out degree in test data. Now the important thing is number of common people in train and test data. What is the number of common people in train and test data? That is 1.063 million, isn't it? What is that? 1.063 million. Remember, look at this number. What is this? People in my test data is, what is this? Just see what it says. Number of nodes, average degree, number of common people, all these statistics you can see it. Just see 1.78 millions training in training data I have in the training graph. In testing graph 1.14 million, isn't it? If you observe this one, what it says, just same Jupyter notebook, IPython notebook I am following. People in my, just check this one. What is this? People in my test data is this 1144,623, and number of people in train data. What is the number of people in train data? 1780722. My train data has 1.78. It is 1.78 million people, and my test data is 1.14 million of people. And there are common, and there are common of 1.063 million people. This is my let's say test data. This one is, which one is test data? This one is test data. This one is training data. Is it? The middle is 1.063 million. Number of people who are in training but not in test data is 717,597. There are some people who are in test data but not there in training data. That is 81498. This is important. Roughly 7%. Just see, roughly 7% of users are there in training data but not there in test data, which means for those vertices have no other information. That is called as cold start problem. This concept is important, cold start problem, because there are some users for whom I have no other data. I don't have any information about these 81498 in my training data at all, isn't it? They are in test data. They are not at all in training data, isn't it? I don't have any information about these vertices. Which vertices? I don't have any information about 81498 vertices in my training data, any information about these vertices in my training data at all. So for this 81498 people or nodes or vertices in the test data is clueless, isn't it? Because I don't have any information. This is this 81498 is roughly about 7%. There are 7% of my users who are not there in my training data, but who are there only in test data, isn't it? This shows that there is some partial cold start problem. Cold start is basically when I don't have any data, like as we have seen recommender systems. Cold start is, what is this cold start? When you don't have any data for some users. Similarly here, these vertices 81498 vertices, these are the people, we don't have any data in the any information in the training data to be able to predict value for that, isn't it? We just try to go through all the statistics. If we will learn graph featureizations in the next lecture, which is very exciting topic. I request all of you just refer this particular IPython notebook. Just as I told you, I already kept this particular IPython notebook link in my previous lectures description and comment sections. Just see training and test data split, everything is there. Just you have to just see those things and understand. Just say this one, what it says. It says name, digraph, number of nodes, number of edges, average in degrees, average out degree. This is about train and test data, isn't it? That's what we discussed. Again, number of nodes in the training data graph with edges. With edges means label 1, without edges means label 0. Number of nodes in the test. Here it says train, here it says test, isn't it? Just go through these concepts. This code is very simple and straightforward. Anybody can understand this, a layman can understand. Just go through it, try to execute it. If you have any difficulty, please keep a comment. Thank you very much.